Yeah, good evening, everyone. So, joining in, let's start off. Comes on, everyone. So, last thing we just started with this conduction introduction. Let's write down this formula again. So, dq by dt is minus ka delta t by L. Delta t is t final minus t initial. This is the equation for steady state. Now, there's also a differential form. dq by dt is minus ka. So, this is a small temperature change across a small length. So, delta t becomes dt and x becomes dx. This is your differential form, which is valid even for non-steady state. So even if the heat flow is not constant, we can still use this. So this quantity here, dt by dx, is called temperature gradient. So any quantity that changes with position, right, is called rate of change. Any quantity that changes with, anything that changes with time is called rate of change. Anything that changes with position is called gradient. So later on, we will see dv by dx also in viscosity chapter. We call it velocity gradient. So it tells you rate at which the temperature changes. Now, comparison with Ohm's law. So if you have a rod here, let's say the temperature is T1, T2, the heat flow dq by dt you can write this thing as minus ka delta t is T2 minus T1 by L. So you can simply write this thing as T1 minus T2 temperature difference by L by Ka. If you see, this thing resembles a lot if you have a resistor V1 and V2, which is the potential. And if the current in the circuit is I, we can write the current I is equal to potential difference V1 minus V2 by R. Now, this is very important thing in physics. As long as mathematically the equations look same, getting it max doesn't care what do you call it. So if you compare them, this thing looks like, dq by dt is temperature difference. We can replace this with, this is called as heat current. This is your temperature difference. So there it is a potential difference. And this term at the bottom behaves like resistance. We call it thermal resistance. So while solving equations, you can simply write R thermal is length by Ka, and the heat current I dq by dt is simply temperature difference by resistance. Basically, V is equal to IR. Have a look at this. So we can replace each rod with L by Ka, thermal resistance, and we can simplify. You can see the resemblance actually. Remember resistance का formula है? rho L by area. So this is nothing but L by 1 by rho into area. 1 by rho is nothing but conductivity. Rho is called resistivity, 1 by rho is called conductivity. So K ka place mein 1 by rho is there. This property, right, is very important, because see, I'll tell you one thing. You're calling it I, you're calling it dq by dt. What will Max say? Max will say you just change the alphabet, isn't it? As long as the mathematically the equation looks same, Max doesn't care what you want to call it. You can call it I, you can call it voltage or temperature, you can call it resistance or L by K, it doesn't matter. You can copy down this. R thermal is L by K, delta T by resistance, heat current. So everything you learned in school about current electricity is valid here. Series, parallel, everything comes. This idea is important. Again, we are going to encounter something similar in fluid mechanics. There, instead of current, we will say water flowing per second. Instead of thermal resistance, we call it resistance to liquid flow. The wordings will sound similar. Clear? Now, let me write down this again. So R thermal is L by Ka. The first thing is series. One thing here. What is L here? L is the length along the heat flow. Remember, you can't take whatever length you want. What is A here? A is the cross-sectional area perpendicular to the heat flow. Now, this thing is important. Most people don't realize, they just think length and area and the whole thing goes for a toss. Let me show you how they'll frame a question on this. Let's say we have a cuboid here. This is A, this is B, and this is C. So there are 6 faces here: 1, 2, 3, 4, 5, and 6. So find resistance across. Or you can say find thermal resistance ratio. Find ratio of thermal resistance. R12 is to R34 is to R56. Do you remember we did something like this in foundation? Meaning if you have a cube like this, not a cube, cuboid. So case 1, you're saying this point and this point are having temperature. So what is the resistance? In the second case, the upper surface and the lower surface are having temperature difference. Means in this case, heat is flowing from left to right. Here, heat is flowing from up to bottom. And here, temperature is given between the front face and the back face. The heat is flowing like this. You're getting it? So depending on which two surfaces you keep heat flow will be different. Now, can you find the ratio of resistance? I hope the question was clear. We have done something like this in foundation, but even if you don't remember, I hope you got the point. Think of like a battery. You're keeping battery between 1 and 2, find the resistance. Put the battery between 3 and 4, find the resistance. Put the battery between 5 and 6, find the resistance. So depending on which way you're connecting, resistance will change. So I want the ratio of the resistances between 1, 2, 2, 3, 3, 4, and 5, 6. Let's get this. Anyone didn't understand the question, please ask. Lakshika, adjust your camera a bit. I can't see you. People, make sure your faces are visible. Palak, Rehan, adjust your cams a bit. Maulika, do adjust your camera a bit. Answers, people. This one is easy, right? See now, when you go from 1 to 2, what is the length? Length is, heat is flowing from here to here, na? So length is what? Area AA, and the area perpendicular to the heat flow. So this is A by K into BC. Make sense? Is 2, what is this thing then? Here length, L is the length along the heat flow. Heat is flowing from up to bottom, so C by K into AB. This is B by K into AC. Multiply and divide by A square. This will become KABC. C square by KABC. B square by KABC. Denominator goes off. You get A square is to C square is to B square. Yep, right, Lakshika. Easy. So this formula is important. When you say resistance is L by KA, remember this, not only this chapter, we are going to see this 3 more times. L is the length along the heat flow. You can't take whatever length you want. A is the area perpendicular to the heat flow. So it is very important to see that which way is the heat flowing. I hope everyone is clear with that point. Now, Vartika, clear, na? Next one. So that is one small basic problem based on that one definition, L and A. Same thing you're going to see in current electricity there. Any doubts? Anyone not convinced with this, please ask me. Next thing. When do you say two resistors are in series? If they have same current. So you say two resistors in series if they have same heat flow per second. So let's say we have a rod like this and we have a rod like this. Let's say length is L1, K1, A1, L1 conductivity K2 and A2. I can replace this with two resistors. R1, which is L1 by K1 A1, R2, which is L2 by K2 A2. And when they're in series, I can replace them with one single resistor, R equivalent, which is equal to R1 plus R2. So basically the heat flow is same through them. So if you take the temperature difference across them, so V1 by V2, so current is same, na? So V1 by R1 should be equal to V2 by R2. So V1 by V2 is R1 by R2. So in this case, voltage is nothing but temperature difference, delta T1 by delta T2. So this is temperature difference across first resistor by temperature difference across the second resistor across rod. So the ratio of, again, remember, it is not ratio of temperatures, it is ratio of temperature differences. What are V1 and V2? When you say V is equal to IR, what is V exactly? Voltage across the resistance. Means it is the potential difference across the resistor. So यहाँ पे it is temperature difference across the rod. When you say they're in parallel, you should have same potential difference. Here you should have same temperature difference. L1, K1, A1, L2, K2, A2. And let's say we have same temperature here. Same temperature here. So this can be treated as two resistors, R1, R2. This can be replaced by R equivalent, which is 1 by R equivalent is 1 by R1 by 1 by R2. R equivalent is R1 R2 by R1 plus R2. We have done this in school. So if this total current is I, the current will split, let's say I1 and I2. Here the voltage is same, so I1 R1 is equal to I2 R2. So the current or the heat flowing through the rods will be inversely proportional to resistance. More resistance, less heat will flow. Everything you did in school, series, parallel, everything is valid. Only thing, resistance ka place mein it will be L by Ka, the current ka place mein heat flow. Have a look at this. Clear? Next thing. Then we have something called a Wheatstone bridge. This is also quite a common thing. We will encounter this at least in 4 chapters, including this. So what's a Wheatstone bridge? Think of like this. Let's say if this is R1 and R2, R3 and R4, let's call this guy T1, T2 and T3, and let this be T4. Now, just now we saw R1, R2 are in series. So T1 minus T2, the temperature difference, by T2 minus T3 should be in the ratio of R1 by R2. Agreed? If two are in series, the temperature difference is inverse straight proportional to R1 by R2. Similarly, T1 minus T4 by T4 minus T3 should be also proportional to R3 by R4. So if R1 by R2 becomes equal to R3 by R4, then you can see by comparison, T2 should be equal to T4. Does it make sense? If everything is same on the right, if everything is same is on the left, then the only thing that is different is this T2 and T4 here. Is that making sense? So that means if there's a resistor R5 between them, R1, R2, R3, and R4 is there. You take this point as A and B. If this is important, if it's not every time, if R1 by R2, the ratio becomes equal to R3 by R4 ka ratio, then VA is equal to VB or TA is equal to TB. Therefore, R5 can be removed. So basically, R5 is useless. If the potential difference is same, will the current flow between R5? So therefore, this circuit can be simplified into 4 resistors. R5 can be removed. If you see this, you can't solve. It is not series, it is not parallel, it is nothing. But the moment you remove R5, your life becomes simple. This is called Wheatstone bridge. So that is a derivation actually for this, but this is the idea there. So if the ratio of the resistance is R1 by R2 becomes R3 by R4, anything between A and B, that R5 can be removed. Do have a look at this. Clear? Let's see a question. Turn the page. Any doubt so far, please ask me. Anyone not clear with any particular part here? Perfect. Next one. So we have two rods. Length L, K, area A. Let's say this is length L, K, but area is 2A. Let's make this radius R. Let's make this radius 2R. So matlab area is 4A. This side the temperature is 2T naught. This side the temperature is T naught. This is your interface. So the ends are maintained at constant temperature. Somehow someone is maintaining the 2T naught and T naught. The ends are maintained at 2T naught and T naught. Find R thermal. Find the thermal resistance of this whole system. Find dq by dt, the heat flowing per second, and find temperature at the interface. Let's get this. We have two rods here, length LK, radius R, length LK, radius 2R. The heat is flowing from left to right. Find the thermal resistance, find the heat flow per second, and find the temperature at the interface. Anika, Ali, question is clear? Anusha, Maulika, question is clear, na? Rehan, Alaksh, Neil. Chalo, try everyone. This week there is no test. I know most of you are having exam, but I kept an additional paper in the group, which is there till next week. It's a full portion from kinematics to rotation. So that will be a good mechanics practice. $60 by 5. Okay. Some, I don't know, might be right. Let's see. What is R thermal, everyone? Let's start from there. I'll help you out with one. See, I can replace this with a resistor. I can replace this with a resistor. So this is R1 L by K pi R square. R2 L by K pi 2R whole square. So if I call this R, this will be 4R. Agreed? If I call that R, this is 4R. So therefore, R equivalent will be R1 plus R2. So that is 5R. So what is the heat flow? dq by dt is nothing but temperature difference by equivalent resistance. That is 2T naught. So T naught by 5R. R ka value you can substitute directly. R is how much? L by K 4 pi R square. Got this? I'm keeping everything in R just to keep your life easy, nothing much. Now, here, this point ka temperature is 2T naught. This point ka temperature is T naught. Let this point ka temperature be Tx. What is same in both of them? Current. Therefore, current I, now see again, temperature difference across the resistor, that is 2T naught minus Tx by its own, this resistor, which is 4R, should be equal to current, isn't it? The current in the total branch should be also equal to the current in each resistor now. So this is also equal to Tx minus T naught by R. Does that thing make this equation making sense, everyone? The current in the two branches is the temperature difference across one resistor by resistance. So that will be 2T naught minus Tx by 4R and Tx minus T naught by R. RR will cancel. This would be 2T naught minus Tx. 4 will go that side. It will be 4Tx minus 4T naught. So this will be 6T naught is equal to 5Tx. So Tx will be 60 naught by 5. Right, Lakshika? Is this making sense, everyone? So the idea that I used is, since the current in both is same, let the temperature at interface be Tx. So 2T naught minus Tx by this resistance should be equal to Tx minus T naught by this resistance. So I jayega. That's the reason I'm writing in terms of R. Who will write L by K, pi R square and everything? Anyway, it's going to get cancelled. Got the idea? Let's see one more like this. Anyone not convinced with any particular step here, please ask me. Aditya, clear na? Yasha, Swastika, Vartika, clear with this? Can I turn the page? You guys try this thing. Something similar. You can put a star for this question that comes in 4 chapters. Quite a standard model. So we have a rod here, L, K, area, 2L, K, area. This is L, 2K, area. This point is A, this point is B, this point is C, and this point is D. So temperature at A is 3T naught. Temperature at B is 2T naught. Temperature at C is T naught. TD, I don't know. So find TD and heat flow in each rod. This is in steady state. What do you mean by steady state? Temperatures have reached constant. Temperature at each point is constant. Temperatures are not changing with time. This is steady state. So temperatures at A, B, C, D all have become constant. Let's get this. It's a good one. Idea is something similar. Let's see how will you approach this. Try. I'll give you 2 minutes. Anyone confused with the diagram, please ask. Okay, we have one answer. Right, Anika. We have 2 answers. Let's see. 80 naught by 7. No, Adrit. That looks wrong. Maybe, I don't know. Meaning other people got different. No, 3 people got the same answer. Adrit, you might be wrong. Check it out. See, listen again. The idea in this question is, tell me one thing. Whatever heat is flowing from here, let's call it I, and let this be I1, and let this be I2. So can I write I is I1 plus I2. Fair enough. The heat flowing from A to D should be equal to heat flowing from D to B plus D to C. You might ask, sir, how do you know heat is flowing that way? I don't know. So let's assume the science will take care of it. So what is the heat flowing across a rod? Temperature difference, that is temperature at A minus temperature at D by resistance of that rod, L by Ka. This is I1 is temperature at D. So we are always assuming, heat is flowing from higher to lower. So D is more than B. That's what I assumed. I'm assuming D is more than B. So DD minus TB by 2L by Ka plus TD minus TC by L by 2Ka. L by Ka cancels off. This will be 3T naught minus TD. This guy will be TD minus 2T naught by 2. This is TD minus T naught into 2. Bring all T naughts to one side. 3T naught, T naught, 6T naught. Bring all TDs to one side. TD, 2D, 3D, 7TD by 2. TD is equal to 12 by 7 T naught. This is definitely less than TB. So my assumption is wrong. I'm getting a negative sign. So if you see I1 ka value, which is TD minus TB, that is 7 to 14 minus, so minus 2T naught Ka by 12. The negative sign indicates heat is not flowing from D to B, it is flowing from B to D. Got it? So once you got this, take this TD and substitute here. You will get the current in each one. You can find I1, I2, and I. That is the heat flowing through each rod. Please check the steps. Yeah, you just need to take TD here. If you put it in this, you get I1. Put this, you'll get I2. Put this, you get I2. I1, I2. That is the heat flowing in each rod. This is a good example. You take whatever sign you want. आप ऐसा भी assume कर सकते. You can take I plus I1 is I2. It doesn't matter. The science will take care. Please check. I and I2 will come positive. Right? They won't be negative. If you want, I can show you one more. What is I? I is 3T 3 minus 12 by 7. That is 9. 9T naught Ka by L. Clear? Easy? Good one. So basically heat flowing from A to D is D to B and D to C, and then you just put the science will take care of it. See where others have gone wrong. People who got an answer different from this, see where you goofed up. Okay, you assumed up. It doesn't matter, meaning you assumed this way. Nothing wrong, but yeah. But think about it, heat goes from high to low temperature. So yeah. Any doubts on this? Udyan, clear with this? Aryan, Adrit, got your mistakes? Aditya, clear, na? Rehan, Aryan? Let's see one more. So we have 7 identical rods. So all rods are length L, K, and A. This is A. Temperature A is 2T naught. This is B. This is C. This is D. This is E. This is F. And temperature at F is T naught. Find heat flow through each rod. And temperatures at B, C, D, E. Instead of A to D, you took D to A will affect the answer. Meaning, how do you take the remaining currents? Adrit? बोलो ना एक बार माइक अनम्यूट करके.
I just took the opposite of it.
Instead of लिया. Then you should take I1 plus I2 plus I is 0, na? The total heat flowing from D is 0 because you're not getting any heat here. Got my point? You're assuming the point D is giving heat to everyone, isn't it? Fine, ले सकते हो. But then what's the total heat given by D? Zero, right? Because D himself has no heat. That way.
Okay.
Let's get this, everyone. What is this? Wheatstone. Hope you figured it out. Try. Get it. You got 3 minutes. Find the heat flow through the rod. Find R thermal and then find the temperatures. Anyone confused with the diagram, please ask. 7 rods, identical. So just a suggestion, okay? When you get a question like this thing, simply draw resistors. That will be easy for you to understand because you guys are already used to solving circuits. So each resistor is L by K. So replace them with R. So it will become more easy to see. Because every time writing that L by K looks like it's weird. Yeah, you can, but yeah. So here it's a Wheatstone bridge. So CD can be removed. No heat will flow. So what is the point of keeping that rod? Take them as R. Aryan, just look at your answer. Does it even make sense? Understood the mistake. You have created free energy. Let's get this. A, B, F, I by 2. Okay, get the temperatures. Get the temperatures. Try. I'll give another minute and a half. There, this is the circuit I would have drawn. इसका equivalent निकालो. Parallel, series, parallel. Hmm. Right, Anusha. Find the temperature. That's a good one. B, C, D, E. T naught by 2. Let's see. Now, if I assume current I is flowing here, what is the current here? I by 2? I by 2. Do you agree? I by 2, I by 2. Symmetry, na? This will be I by 2. This will be I by 2. And this is again I. Now see. What are these rods? So this guy is A, B, C, D, and D. So if I talk about the rod AB, current I is what? Temperature difference TA minus TB by R. How much is this? So I is nothing but T naught by 3R. TA is 2T naught. TB I don't know, and resistance is R. RR will cancel. We get T naught by 3. So we end up with TB is equal to 5 T naught by 3. You have to do that like that for each rod. Makes sense. Similarly, if I do for B and D, it will be I by 2 is equal to temperature. So basically, you're always assuming heat is flowing from higher to lower. So B is greater than D. So TB minus TD by R. So I by 2 is nothing but T naught by 6R. TB is 5T naught by 3 minus TD by R. If you solve this, you get TD is equal to 3T naught by 2. By symmetry, you can say C and D will be having same temperature. And C also will have same. Similarly, if you do for EF rod, I is equal to TE minus TF by R. If you do this, you'll get TF is equal to 4T naught by 3. Check your answers. That's how you find temperature. If they ask you temperature anywhere in the midpoint, always cut it there, right? So temperature difference from the point which you know to this unknown point by resistance should give you the current. Does that make sense? Do have a look at this, what I did. I scribbled it a bit, but yeah. Hope you got the idea. Anyone not clear with anything, not convinced, please ask. Got it? Can I go ahead? Malika? Clear, na? Swastika, got this? Did you guys solve that recent rotation ka paper? Paper was good. Questions were little different. It is a proper good paper actually. Again, see all the papers that I'm conducting, right? Please don't ignore them because all these papers, if you see, I am taking questions from this Chaitanya, Narayana, Fiji, Ellen, all these different institutes, especially unka grant test papers hai ye sab. These are not their regular institute ka weekly papers. When the portion gets over, for the seniors, they do a revision, right? So they have some special grant test papers. So I'm picking out questions from there and I'm making papers for you guys. Getting it? So, and if you see the papers which I'm putting, right, all of them, they don't look that easy, right? They're fine. Maybe sometimes moderate and tough, but there's nothing as such very easy. I do keep once in a while. So, especially the advanced papers, don't ignore them. It's okay if you score less. Why bol raha hu? In that paper out of 80, it's fine even if you have scored 25, 30. But if you resolve and learn, you will find a lot of new things in that. You're getting it? See, every exam is not to score. आपको score करना है आपका major test में. If you become obsessed with score in every damn exam, right, you will stop learning. So forget about that. The score is simply telling you how much you know and how much you don't know. So don't become obsessed with that. So write the papers. Because I'll tell you, even your seniors, even this last year, most of them, right, were scoring in that range only. People were scoring in the range of 40% to 60%. Yeah, some people are doing good. This paper, if you see, right, it was written by your seniors also. मैं उनका नाम भी include कर लिया इस बार. So those were the scores actually, around roughly in that range only. Now in that, there is a guy called Chinchan. I don't know whether his name is there or not. He is the one who got 100 out of 100. Physics में full marks आ गया था उसका. तो पता नहीं उसको कितना है उसमें. So don't think of so the papers are good. The reason I'm telling you the source is also because of that. And especially most of the questions I take is like there's a campus called China campus in Hyderabad. अभी नहीं है, but I used to work there long back, 2011, 12 times पे. So every year out of 100, they used to get 20 ranks in top 100. Getting it? So they have a pretty good content. So let's see next one. And same thing, you wanted to release some tough questions, right? You can see my booklet level 5, level 6. Those are also from the same content from Hyderabad Institute. It's an institute by Chaitanya and Narayana together. Those two are big players in Andhra. That's why it's called China. अभी समझ में आया नाम कैसा है? चैतन्य में CH और नारायण में वो that whatever NA. It is not a campus from China. People used to think China से कोई आके IIT पढ़ा रहे हैं आप. Let's see one more. So we have two parallel plates. The left side is filled with one material, K. This is also a good question, right? This will again come in chapter called capacitors. The right side is filled with 2K. The distance between them is d by 2, and this area is A. Area of that plate. So here temperatures are maintained between this side and this side. So 2T naught and T naught. So heat is flowing from left to right. Able to visualize? So the room you're sitting in, left half is filled with one material, right half is filled with one material. Heat is flowing from left to right. The second case, I'm not drawing the full thing now. You filled up the top part of the room with K, the lower part of the room with 2K. Here the area is A by 2, area is A by 2, and the width is D. Again, heat is flowing from left to right. It is important, I need to tell you, or else what will happen if the heat flows from up to bottom, it will be reverse, no? If the heat flows from up to bottom, then what will be the area? This will be the area, isn't it? And this will be the length. So that thing is important, heat is flowing from where to where. Then C question. Let's say this is K, this is 2K, this is 3K. So basically A by 2, A by 2. So left half of the room you're filling with one material, right half you're filling with two materials, up and bottom. Even in this question, right, if you ask me, C is even more important. Let's get this. Find R equivalent. In all the cases, find the equivalent resistance. In case you're confused, I'll help you with one. The first one, if you see it, I can write this thing like two slabs, isn't it? So I can treat them as two resistors. D by 2, area is A. D by 2, area is A. This is K. This is 2K. So this can be written as one resistor and one resistor. Its resistance will be length. Length is D by 2. K, area. This resistance is D by 2, 2K, area. So this is R1. This is R2. So R equivalent will be R1 plus R2. So that will be D 3D by 4K. Easy. That way, you can just split the left and right into two parts and solve. They'll become two resistors. What is the formula for resistance? Length by K into area. Length is the length along the heat flow. A is the area perpendicular to the heat flow. Try B and C. C is the main question in this. A and B are just like for you to get a feel. If I ask you in the exam, I'll ask you C directly. Ditto question we'll do in capacitors. There we'll call K as dielectric constant. Get B, everyone. B is easy. You got a minute for that. Okay, B is also fine. B can be written as like this, parallel. The upper one is K, the lower one is 2K. So the upper one is length is D by K, area is A by 2. This is D, 2K, area is A by 2. And 1 by R equivalent is 1 by R1. So Ka by 2D plus Ka by D. This guy is 3 by 2 Ka by D and inverse at 2D by 3K. That's your B. Check. So up and down both are in parallel because they are the same temperature difference. Let's see what people will get C as an answer. Any doubts on A and B, please ask. Okay. Let's see. So this thing can be written as, so 1 here, here. So this is filled with K. This is filled with 2K. This is filled with 3K. So this is a blunder. If you have done this, it's a blunder. अभी क्या करना है? And this is what everyone will do, and इसका option हो गया exam में. Now someone tell me why is this a blunder? Area is not same. अरे A by 2 तो दिया ना रे God, area तो same है. Let me ask you this thing. If you have, let's say, Mumbai to Pune, there are 2 roads. ठीक है? First road is proper highway. Second road, first half is exactly same, but the second half is bad. Do you think same amount of traffic will go in both the roads just because the first half is same? It depends on the total road, isn't it? Now, same way, tell me one thing. Do you think the upper half and the lower half are identical? If the upper half and the lower half are not identical, that means at this interface and this interface, do you think they'll have same temperature? So this will have some temperature T2. This will have some temperature T1. Since upper half and the lower half are not identical, the temperatures at the interface is not same. If temperature at the interface is not same, then is the potential difference not same, right? Therefore, temperature difference across 2K and 3K is not same. Just because they're side by side doesn't mean then parallel. Parallel का definition क्या है? Temperature difference should be same. Temperature difference across 2K and 3K is not same. So done. That's why they're not in parallel. Then how to do this thing? You have to split this into 4 parts. Because whatever heat is flowing in K, the upper part will flow through 2K. Whatever heat flows in the lower part will flow through this guy. So this would be K, K, 2K and 3K. So we have 4 parts. So each one ka length becomes D by 2, area becomes A by 2. So you can treat this as 4 resistors. So this guy will be D by 2, K, A by 2, which is D by Ka. So this is also D by 2, 2K. So this is D by 2K. Because A by 2 and D by 2 will cancel. This is D by 2, 2 and A will cancel, D by Ka. And this is D by 3Ka. Upper two are in series, bottom two are in series, and the whole thing is in parallel. So yeah, Yasha, you got it right. Lakshika, you also, I think so. So then if you add series parallel stuff, what do you get? The upper one will be 3D by 2Ka. Lower will be 4 by 3, 3 by 2, 4 by 3. C3 will cancel, 2 by 3 by 2 plus 4 by 3. 3, 3, 9, 8, 17. ऊपर आएगा 6. Yeah, you guys are right. 12D by 17 Ka. Clear? You can ask even one more better question. Which interface has more temperature, upper interface or lower interface? If the temperatures are not equal, can you tell me who will have more temperature, T1 or T2? That would be a pretty good question, even at an advanced level. So K, you're saying 2K, 3K का interface का temperature is not same. That means they're different. So who is more? मुझे answer पता नहीं, even I have to solve. Let's do some betting. Who thinks T1, T2? Guess. Yeah. Solve, figure it out. I'll give you a minute. It's a good one. I hope everyone agrees, right? T1, T2 same nahi hai. Any doubts on this concept, please ask me. That is the reason this question is pretty good. Because most people think 2K, 3K in parallel, and that option will be there. So there, we are clear now. Upper interface, lower interface are a different temperature. So the question is who has more? It requires little working actually. I don't think it is something which you can see and tell that easily. I'm not sure though. Try. I'll give you a minute to figure it out. Which interface has more temperature, the upper one or the lower one? Should I tell you how to approach? Try. I'll give you a minute. This is what I would do. So this thing is there now. Let me replicate this diagram here. Let's write in terms of R, okay? This is R by 2, R and R by 3, where R is d by Ka. So this temperature, let's say 2T naught. This guy is T1, this guy is T2, and this guy is T naught. Now, there is no way out. You literally have to solve for T1, T2 there. Now, another problem is, you know what? This current is I1, this current is I2. Currents are not same. Symmetry nahi hai. So for the first one,
सर आपने
I1
original question में 2T naught T naught दिया था?
दिया नहीं, मैंने कुछ भी डाल दिया. You also can take anything you want.
अच्छा, okay.
You want to take TA, TB? ले सकते हैं, कुछ issue नहीं. It'll be just, at end of the day, I'll just write delta T. So 2T naught minus T1 by R should be equal to T1 minus T naught by R by 2. So if you solve this, how much you get? RR will cancel. 2T naught minus T1, we will get 2,1 minus 2T naught. T1 will be 4T naught by 3. The second guy, I2, 2T naught minus T2 by R, T2 minus T naught by R by 3. If you want to make your life more easy, I'll just take this 0 and I'll take this as 100. Because if you just want to find who is greater, it doesn't matter what you take. This guy will be 2T naught minus T2 by 3, T2 minus 3T naught. T2 will be 5T naught by 4. Who is greater? This guy is 1.33 T naught. This guy is 1.25 T naught. T1 is greater, na? Clear? You will figure it out. Maybe we could have guessed it a bit, but don't know because answer hai abhi lag raha hai we can guess, but not sure. What I was thinking, na, see, the lower one has 3K, means what? It is more conductive. The heat can easily flow. That means it requires less temperature difference for the heat to flow. Think about it. If you're pushing current through a resistor, right? But again, the problem kya hai na? And that means I'm assuming currents are same in both. That's a problem. So that is the reason initially I hesitated, but ठीक है, I think let's not do that. Upper rod has less resistance compared to, हाँ वही है, meaning that just too many things coming up. Current is different, resistance is different. I won't do that. I won't have guts to do that in the exam. I will do this only. So that's what I'm saying. If you're not going to do it in the exam, let's not do it in the regular practice also. Clear with this? It's a good question. So if you see, I can ask this as a paragraph. I can ask you find R equivalent. I can ask you which temperature is more, or I can ask this as a mostly more than one choice question. That will be a pretty good one. Clear? Next one. Next one. Again, I didn't teach you anything. We are just playing with the one equation, dq by dt is Ka delta TBL. We have a container here. This is a water vapor. So this is 100 degrees boiling water. On the other side, you have a 0-degree ice block. You connected both of them with a rod. So let's call this point A. Let's call this point B. So somewhere for this rod, you kept a flame, a heater, and you're sending heat through this. So at this point, the temperature is 400 degrees. Point P is maintained at 400 degrees by a heater. Heater, burner, whatever you want to call. And assume there's no other heat loss. Now tell me, heat will flow from where to where? Heat will go from P to water. It will also go from P to ice. Na? Heat will flow in both the directions because P is at higher temperature. So the question is, it is observed the mass of ice melting per second is equal to mass of water vaporizing per second. So how much ever steam is being produced, same amount of ice is also melting. Find AP by BP.
Length find करना.
Yeah, find the ratio of AP by BP. मतलब, where do you keep the flame exactly? सोचो ना, if I keep the flame too close to ice, won't ice melt more? And I hope you remember latent rate of fusion and vaporization ka values. Rata marna hai, that you need to know. In case you forgot, latent rate of fusion of ice is 80 calorie per gram. Latent rate of vaporization is 540 calories per gram. There, conduction and calorimetry, a little bit of calorimetry. I hope the question is clear. We have water on one side and we have ice on one side. You kept a rod and there's a heater. The heat is coming from the heater to both of them. And it is observed same amount of ice is melting and water is vaporizing. So where did I keep the heater exactly? Try. It's a good one. Just give it a try. I'll just get some water and come. Any answer? 24 by 216. Can you simplify that more? That is 1:9 in the record. ना simplify नहीं कर पा रहे हो. एग्जाम में ऐसा इतना weird आंसर कौन देगा ऑप्शंस में? लक्षिका, अनुष्का, yeah, that looks right. हाँ आर्यन, I think you did get the answer right. Simplify ना रे. There is one of your senior idiot who did this in this exam. Recently उसका mains exam है. I think he got something like, exactly याद नहीं है, but I think it was something like, uh, it's a very weird thing. He got something like 4 by 12 and he's checking where is the option. Options में 1 by 3, 2 by 3, 4 by 3, 5 by 3 ऐसा कुछ था. And this guy is like, sir, there's no option. Bonus देना चाहिए. I said, bonus क्या? I felt like slapping him in front. So होता है मतलब. I do know. People do pretty weird things in the exam. How to do? See. Now for AP, dq by dt will be K, A, temperature difference, which is 400 minus 100 by length is AP. And remember, whatever heat you're sending here, this will be mass into latent heat of vaporization. for BP, dq by dt, let's call 1 and 2, okay? K, A, temperature difference is 400 minus 0 degrees by AP, sorry, BP. So here, whatever heat is going is for M into, this is actually by time only, because M is mass per second, na? LF, divide them. If you divide these two, you end up with MLV by MLF. KA will cancel. You end up with 3A by AP, 400 by BP. This guy is 80 by 540. This guy is BP by AP, 3:4. 0, 0 will cancel. AP by BP. Did I goof up somewhere? No, I goofed up somewhere. This 540 tha ye. 0, 0 will cancel, and that would be 18 by 1:9. Easy. Check your steps, and kind of you could have guessed it. Meaning not the answer. You could have guessed this much. The heater should be close to the water because it takes 540 calories per gram. And उसको ऊपर से temperature difference भी कम था ना. It's only 300 difference. Here it is 400 का difference. So you need more heat, and your difference is also less. So that means you should be closer to the water. Clear? Easy one. Did you notice something? अभी तक integration आया नहीं. Next thing. This is just all starters. Main को start नहीं हुआ अभी तक. Let's do some 1 or 2 theoretical questions before going ahead. Can I turn the page? Any doubts? Palaksh, clear, na? Rehan, Udayan, got this? Neil, Malika, Vartika? Perfect.
तो dm by dt होता है ना वहाँ पे
ये हाँ, this is mass per second.
अच्छा आपने अच्छा बोल लिया
Directly हम लिख anyway cancel हो जाएगा ना, तो I just wrote M by this thing. Next thing. These are some theoretical questions. Let's say a metal and a wooden block are placed in a hot room. Initially, both have same temperature. The question is, just after a few seconds, after few seconds, after few hours, who has more temperature? See, if I try to plot the graphs, that would be actually a better question. Which of the following is the graph for temperatures? Temperature versus time. So just after a few seconds between metal and wood, who has more conductivity? Metal, na? So metal will take away the heat faster. So metal ka temperature will rise pretty fast. And then becomes constant now. There is a limit, right? Your temperature can't be greater than the room. What about the wood? Wood has low conductivity. So it will take heat slowly, catches fire only. अरे fire में catch करेगा रे. इतना इतना भी hot नहीं है रे रूम में. तो ऐसा बोल रहे समर में अगर टेम्परेचर 45 हो गया तो घर पूरा जल रहा है, मतलब बिल्डिंग इज ऑन फायर. दिस इज नॉट चाइना रे. इंडिया में इतना भी पोर कंस्ट्रक्शन नहीं है. You heard recently someone launched a firework, it went and hit a building in China. 40th floor or something, building got fire. Normally India mein na, we use metal and everything to do construction. These people are using bamboo sticks. It's called tofu construction. So wood का क्या होगा? It will rise slowly. Eventually, if you leave it for hours, eventually both will have same temperature, isn't it? Because equilibrium, na, eventually wood and the surrounding should have same temperature. Don't burn the wood. So first one ka answer will be metal. After long time, both will have same. Is that making sense? Eventually, right? You'll keep absorbing, eventually reach the temperature of the room. So initially metal absorbs fast and becomes constant. Because K is more. But eventually, temperature of metal becomes equal to temperature of wood, becomes equal to temperature of room. So this is what I was saying last time. So when it is very cold, right? If you touch metal and wood, which will feel more cold? Metal. Even though both have same temperature, you still feel metal is more cold. So what you are measuring or what you are sensing is not temperature, but heat flow. You think metal is more cold, not because it has less temperature. It has more conductivity. So we humans, right, are not sensitive to temperature. We are sensitive to conductivity. When you touch something and you feel cold or hot, what you are seeing is actually heat transfer. We humans are hopeless. We can't measure, we can't figure out temperatures. Getting it? That way. Meaning our species is only weird actually. I don't know how we became the survivor of this world, but we should have gone extinct long back. The only thing, that humans have, right? Only when things go bad, then we get superpowers. We start behaving very differently. It's like, imagine you have 30 days for the exam, right? And if you try to plot your efficiency versus time, let's say this is the deadline, 30th day. So day 0, people are at negative. 30 days है कुछ भी करेंगे बाद में, chill out types, right? After 1 week, people don't even know there is an exam. I think 2 weeks down the line, अरे पता है 15 days में एग्जाम है. हाँ रे, हाँ एग्जाम है, सुना मैंने. सिलेबस कुछ आइडिया है क्या? हाँ कुछ तो मैं भेजता हूँ ना शाम को, इवनिंग आई सेंड इट. ओके ठीक है. I think 1 week before the exam, अरे कौन सा एग्जाम? क्लैरिटी आया, हाँ रे, इट्स so and so exam, this is the syllabus. Books देखा तूने? If it's the meaning depends. I'm just talking in general, okay? Some sincere students will study from day one only, like you guys. If you don't study, then there'll be a teacher like me who's shouting from behind, पढ़ो. So that's a different story. I'm talking in general. IITians का तो ऐसा ही होगा. Once in IIT, this is the exact graph you will see. And then you'll realize there's an exam. You'll put the books on the table. They are there on the table. So it is a concept of diffusion. When you put all the books in the room, due to diffusion while you sleep, some of the subject will enter your mind. So that is a concept. So you buy all the books and keep it in the room ready. So diffusion is happening right now. So subject is, and some people are too smart. You can put the book under the pillow also. So diffusion rate will be faster. So you can get absorbed more. And then I think 2 days before you realize, shit, kuch to karna padega abhi, right? And now you start doing something, but you're bored. 12 hours before the exam, you're at peak level efficiency. You have become a god. You are just studying everything. You are reading 400 pages in 12 hours and understanding everything. Full night out. Morning 8 o'clock is the exam. You didn't sleep full night. 7:45 you go to the cafe and you drink 2 coffees, concentrated. Then you go to the exam. 8 to 11 o'clock, 3 hours exam. You write for 2 hours and then you're gone. You're slept off the exam. 2 घंटे में कितना हो गया इतना हो जाएगा. You will score some 60, 70 between out of 100 and you feel proud of yourself. Oh, मैंने इतना कर लिया. And then you come out and brag, अरे मैंने सिर्फ 12 घंटा करके 60 marks आया. If you had studied for 12 days, I would have scored 1,000. तो मतलब this is what you do in IITs also. There is a story. I don't know how true it is. There is a professor from some abroad university, right? He came to India to see like, यार यहाँ पे education कैसा होता है. So that day he entered the college and he found like, the library was full. Students were studying till night 12 o'clock. Students have gone mad. And this guy was impressed. He said, I have never seen, a place where people are so obsessed about studying. So this guy went back to his country and he applied for the Indian University. कुछ IIT था. He thought like ऐसा students को पढ़ाना है मुझे. मतलब people who are so much into studies. This guy applied. He became a professor in IIT. Now again, I really don't know how true is it, but might be possible. I think it is IIT Kanpur actually. So this guy joined as a professor. And then when he came, he found out the library was empty. कुछ भी नहीं कर रहे. People are doing all weird things, and this guy was confused. Then he had a talk with another professor and said, "Sir, what day did you come exactly?" So he came during the exam ka period. वो भी final semester का exams था. So during that 1 week, he will see like that only. Environment is people are on fire. After that, people don't give a damn about it. I don't know what happened with the professor after that, but yeah. Take a break. Come back by 7:05. We continue from here. Any doubt so far? Anything that you're not clear, please ask me. Chal, come back by 7:05. क्या बोल रहा था, कुछ कर रहे थे? Chal, let's start off. Sure, let's see one more like this. Let's say I have a bowl of water. So you kept a heater and you have a flame and all that. So this is 100-degree boiling water. And remember, until unless all the water will vaporize, temperature will not rise. Now what you did, you brought a steel glass and you place some water on it. This is a water in a steel glass. Ever did this thing? Let's say you have a milk to drink and it is too hot and तुझे late हो रहा है. And what does mom do? Mom puts the milk in the glass and puts in the water to cool down. Okay? So water in a steel container is placed inside. So the question is, will the water inside the glass boil? Will the water inside the container, inside the steel container, is my question clear? You have a boiling water. You have a flame, everything, so you're giving heat condition, water is boiling. Now you took a steel glass, उसमें थोड़ा पानी डाल के, and you kept it inside this boiling water. So my question is, will the water inside that steel glass boil? Yes, no, and why? The why is the more important thing. Yes and no is easy, right? Half of you can say yes and half of you say no, and half of you will be right. That's how actually, people do scams. This is an old scam. What people used to do now, let's say there's an India-Pakistan match. And let's say it's a series of 7 matches or 10 matches. You know what these idiots used to do? They used to send mails or letters or something. They used to select some 1 lakh people. Let's take a round figure. Let's say 1 lakh people. You have a 1 lakh email IDs or something. For 50,000 people, you send India wins, and for 50,000 people, send Pakistan wins. India or Pakistan will win. So half of them will be right. So these guys will ignore. These guys will think, okay, ये तो predict किया, ठीक है. Then second prediction for these people, right? You send half of them, India will win, half of them Pakistan will win. Let's say Pakistan wins now. This group is right. Again, you send a prediction, 12.5 and 12.5. One of them will win. Now you have the attention of these people. Because I sent you 3 mails and all the 3 predictions are right. Isn't it? Now you start thinking, maybe this guy knows. For this 12.5, again I'll send 6,000, 6,000. One of them will win. Now this 6,000 people are right, what, 4 times in a row, right? Now you start feeling maybe these people really know how to predict. Then again I'll send 3,000, 3,000. Now these 3,000 people will be convinced, 5 times in a row, how can someone be right, isn't it? 5 times in a row, you predicted who will win India-Pakistan match. Now this time I'll send a mail for this 3,000. As you have seen, we are right 5 times in a row. Right? For the 6th prediction, you have to pay 1,000 rupees. You're getting it? And now you'll trust me. Out of 3,000 people, I have shown you that 5 times my prediction is right and I gave it to you for free. So अगर आपको 6th prediction चाहिए, तो you have to pay 1,000 rupees. Right? Now, assuming everyone pays, or let's say even half of them are ready to pay, now 1,500 and 1,500, half of them will be right. Now I'll send a mail to them. As you have seen, my 6 predictions have been right. For the 7th prediction, it is only 5,000 rupees. Now these people will start betting their money, because betting matches, if I know what I'm going to win, won't people start betting? So people are fine with it. अरे 5,000 rupees यहीं पे दे देंगे, वहीं पे bet में 1 lakh डाल देंगे. Make sense? Then half of them will win 750, 750. For 750, eighth one, I will charge 10,000 rupees. Then 750 again, half of it. India Pakistan final match, ninth match, let's say. I will say it is 1 lakh rupees for the final prediction. And now people who have won 8 times in a row, they will be like, "Arey yaar, ye to ho jayega bhi. 8 times I'm right in a row. So 9 time they'll pay." How much money is this? 3,000 into 1,000. I think that is 30 lakhs. That's how you make money. Permutations and combinations. You take a large sample and you start sending mails. There'll be definitely one part of the crowd who will always win. What is the answer here? No, the temperature would be always less than the glass. Nee, dekho na. Now, look at the catch here. What is happening? Outside the water is 100 degree. I know what you're trying to say. It will be always less initially. Now, as long as the temperature inside is less, heat will keep flowing. Once the temperature inside also becomes 100, whatever heat is coming in, it will start going out also, no? So where is the extra heat to boil the water? Are you getting my point? The moment water inside the glass ka temperature becomes 100, conduction will stop. And if there's no conduction, where are you getting the extra heat to boil the water? Is that making sense? The water will never boil. So the answer is no. So the reason when temperature of water inside and outside becomes 100 degrees, conduction stops, heat flow stops. That means you're not getting any additional heat from outside to inside. I hope that is making sense. Heat flow stops. Therefore, there is no additional heat to convert water into steam. Easy. The simple questions, but yeah. Clear? Next one. We have a truncated cone. Again, another standard question, right? Result is very important, comes in 3 chapters. Elasticity, thermal expansion, this thing, heat transfer, and current electricity. So this side ka radius is A, this side radius is B. This is called truncated cone or frustum. Truncated cone meaning you take a cone and upper part na cut it off. So this point, right, is length L. So this is x is equal to 0 and this is x is equal to L. Conductivity is K. So this side temperature is 2T naught and this side temperature is T naught. Find thermal resistance. Find the thermal resistance of this truncated cone. L should be much, much greater than B minus A. So the second question is, what happens if L is not, what is the problem if L is not greater? What happens if L is comparable to B minus A? That would be a very good question. So this question can be solved only if the length is much, much greater than B minus A, where B is the right side radius and A is the left side radius. Quite an important question, comes in 3 chapters. How do we do this? Think for a minute, then I'll ask you something, then I'll give you more time. How do you approach this? So this result, what we get, we are going to skip this later on. We are going to, yeah, you have to integrate. Game has started. Meaning you can clearly see, right? When heat is flowing from left to right, each part has a different area, na? Area constant nahi hai. So you can't say L by K. That is how you know integration has come into the picture. Yeah. I'll just help you with one thing. Can you do this thing for me? At a distance x, एक छोटा disk लिया. Can you find the radius of this disk as disk? Find the radius as a function of x. Start from there. Get it. For this truncated cone, at a distance x, if you take a thin disk, what will be the radius as function of x? Let's start from there. Get it? That is just mathematical equation. Try. I'll give you a minute. Find r as function of x. B minus. नहीं रे अनुषा, सोचो ना. If I put x0, what should I get? A na. If I put x is equal to L, what should I get? B na. Aryan God, your dimensions are not matching. What are you finding? Use Earth ka max. Let's not use some alien max. Don't scare me. Ah, Lakshika, you got that. Then what? Right, Anusha. See. It's more of a geometry. There are 2-3 ways to do this. If you take this point as origin 0, 0, this guy would be 0, a. So at a distance x, this guy would be x, 0. This would be x, r, the radius of that thing. And this guy would be L, b. Now, if you see, this is a straight line, isn't it? The slope of the line should be same. So slope of that line will be b minus a by L is r minus a by x. So r is equal to a plus x into b minus a by L. This is one way to do. Or if you don't, sometimes it doesn't strike. Since I know it's a linear function, I can write r is equal to px plus q. When x is equal to 0, r is equal to a. When x is equal to L, r is equal to b. This also will give you the same answer. Make sense? I can say it's a linear function and get it, or I can find the slope of the line. Either way, you'll get it. There's a third way also. You can extend the line, make this angle theta, and you can do. But he gets the same story. Clear? Actually, if you want to do with angles, this would be much better. You can take this as theta, and you can find this and get basically you're finding slope only indirectly. Now what? So we got a thin disk here of thickness dx. So this is dx and this is r. So the resistance of this thin disk will be length dx by k and area is pi r square. All these disks are in series or parallel. All these disks in the disk series, right? Because same heat flow. So integrate them. But now this is dx and this is r. So let me get this thing and differentiate on both sides. Dr will be b minus a by l into dx. So substitute here. So r equivalent will be 1 by pi k. Dx would be b minus l by b minus a dr by r square. R ka limits will go from a to b. I'm integrating everything in terms of r instead of x. L by b minus a into pi k, and this integral will be minus 1 by r. Limits will go from a to b. You end up with L by k pi a b. You get a pretty good answer. There. Yeah, I wanted to remember this answer. The answer comes as if L by k, the area is pi a b, geometric mean. That would be your answer. So exams like mains and bits or CET, that direct question you'll get. You won't have time to derive this. Check it out. And we'll not do this derivation again. This is the same idea we're going to use in current electricity. Please look at the steps what I did. Anyone not convinced with anything here, please ask me. Clear? Question still not over. Why the hell this is important? Do all this. Why is this L must be greater than B minus A? What is the catch of that? This is valid if the length is much greater than B minus A. Anyway, let's see what happens if L is much greater than B minus A. If L is comparable to B minus A, can someone tell me how will the heat flow? This is 2T naught. This is T naught. Can you see something wrong with this? Meaning wrong, matlab, can you get a hint from here? What's the catch? In the formula L by Ka, what is A? Area perpendicular to the heat flow. Is this area perpendicular to the heat flow?
No.
You can't write. You're getting it? This area pi r square. This area is not perpendicular to the heat flow. Your whole question is gone. If that is not perpendicular, how will you integrate? Making sense? So what we do in the assumption is L is much, much greater than B minus A. So what you're doing is, this is so thin, matlab, it is almost negligible. Matlab, this difference na is B minus A. Clear? Actually, here also it is not acceptable, but it's so small we can neglect it. We can neglect that error and we can say that is perpendicular. Is this clear, everyone? Heat flow won't be radial anymore, meaning you have to find an area like this. I don't know how will we do that. Clear? So you can't take pi r square as an integral and solve it anymore. The question becomes pretty weird. That is a catch in this question. That's why I keep mentioning those words. L is length along the heat flow. A is area perpendicular to the heat flow. Your basic definition should be very crystal clear. Clear? Next one. Next one. We have a thin cylinder here. Case 1, this side is temperature 2T naught and this side is temperature T naught, meaning the ends are maintained at the temperature. Here, the inside is 2T naught, outside is T naught. So the inner radius is A and the outer radius is B and the length is L. Meaning in the second case, now heat will flow like this. If you look at the side view, heat will flow which way? Radially, na? Heat flows radially from inside to outside. So here it is inner temperature is 2T naught. Find R thermal in both the cases. And here this is the length L. Again, here also length should be much, much greater than B minus A. Let's get this. So we have two hollow cylinders with inner radius A and outer radius B. Length is L. Case 1, the heat is giving from left to right. Case 2, heat is going from inside to outside. I hope the diagram is clear. How do we do this? Lon, yeah. Right, Lakshika. First one will be parallel. Q parallel re Utsa. First is easy, right? First कुछ भी नहीं था. First is what? What is the formula for R thermal? Length is L, fair enough. K by area it flows. Pi into B square minus A square. हो गया एक step में. Isn't it? Heat is flowing only through that thin section there. That's it. B is an issue. B में what is the problem? As you go out, area is increasing, isn't it? A is not constant. When you go from inside to outside, inside area was 2 pi AL, outside is 2 pi BL. So area is changing when you go from inside to outside. So there you have to integrate. Try.
पीछे खाली है सर.
Where पीछे मतलब?
नहीं, बीच से खाली है वो सिलेंडर.
हाँ, hollow ना?
अच्छा अच्छा अच्छा, मैंने 2 सॉलिड
Where,
क्या करी.
hollow ना? These are hollow cylinders with inner and outer radius A and B. Let me write it down for you. वो इतना अच्छे से beautiful diagram भी किया, shading भी किया मैंने. No, I can't draw as good as my wife, but she's a painter. She does really well. I think last time Diwali, I guess, she asked me what you want me to draw. I said draw a peacock. Something like this. And then I said there should be a dinosaur which is chasing a peacock. Something of that sort. She said, what? I said that is two different species which have not at the same time. I said, just imagine, like, peacock is running away and the dinosaur is chasing it. That's the last time I think she asked me. Then after that, she never asked me anything to give an ideas. Initially, she used to come for feedback. I used to say, is this a dog or a cat or a horse? Exactly what are you drawing? Aryan, Adrit, didn't get the first one. What is the formula, God? Heat is flowing where? Heat is flowing in this edge, na? So what is the length? L only. What is the area? This cross-section area, isn't it? What is that area? Pi B square minus pi A square. No?
Where the heat is flowing from
heat is-
inside to outside, right?
First question, right? You said first part, I'll punch you. You said first part. First part is what? Heat is flowing from left to right.
I was solving from inside to outside. Then
That
it
is B
outside
part.
to inside. I was solving outside to inside.
क्या फर्क पड़ेगा outside to inside, inside to outside? This is left right, okay? That is out inside. Clear na? First part is clear na now? Yeah. Let's see the second part के लिए क्या करना है, gods? We will take a thin cylinder. Of radius x and thickness dx. And let the heat flow in the cylinder like this, radially. So for this thin cylinder, it's a thin cylinder of thickness dx. So resistance of this cylinder will be length. Again, what is length? L is the length along the heat flow, which is dx by k. Area is 2 pi x into L. That is the surface area of the cylinder, isn't it? Heat is flowing through the entire cylinder ka surface, na? Curved surface. Are you able to visualize? The heat is flowing through the entire curved surface of the cylinder. Meaning, if I draw the side view now, maybe you'll understand. Heat is coming out like this. Are you able to visualize how it is coming out? Did you ever see this thing? There's a certain type of comb, where you have spikes like this. That round goal wala comb. Kabhi dekha? It looks like that. It is coming out like that radially spikes. बेस्ट थिंग, वो बाथरूम का ब्रश देखा कभी, टॉयलेट वाला? It looks like this and it will be like this na, spiky, cylindrically, radially going out. Able to visualize? I can't give you more examples. हो गया अभी बाथरूम से गंदा का example I don't have. The hairbrush was a good one. I'm sure everyone has a hairbrush like that, which you can roll around. Girls will definitely know. Boys though we don't have an idea, but yeah, bathroom you guys will understand better there. And all these cylinders are what? All are in. I think I might have a diagram actually. Wait, not the bathroom thing, but radial thing. Must have it in electrostatics. Nope. Gauss law. Nope. But wave optics again. No, I don't have it. I'll show you something else next time. Okay, so all are in series. Why same heat is flowing? But anyone still confused, please ask me. And then you integrate them. So R equivalent will be 1 by 2 pi KL integral dx by x. Limits will go from A to B. So that is ln A by B. Ln A minus B nahi hai, God. Ln B minus ln A is ln B by A, not ln of B minus A. Please don't do max like bio students. They do such things. Ln B minus ln A, ln common le lete and ln B minus A. They're capable of doing this kind of stunts. You guys, please don't do such things. Easy. Again, why L should be greater than
It would be B by A or A by B.
yeah, B by A. L must be much greater than B minus A. Why? Problem is here it is not some similar issue, but there is something more thing. The cylinder is too thick. See what happens. How will the heat flow? Heat in the center has no problem. It will go straight, straight, straight. As you come to the edges, the heat will start bending towards the edges, isn't it? If the cylinder is too thick, this side is open, na? So heat will start going to the edges, isn't it? Heat will not flow radially. Heat at the edges will not flow radially. This is something, it's called like a fringe effect. Heat at edges does not flow radially. That means you can't take area 2 pi XL. So that's why it should be very small. So you can neglect it. Remember, we can always neglect it, okay? It is actually there. Do have a look at this. Clear? Next one. Next one is a proper solid one. Right? This should be a proper advanced paragraph question. Any doubts on this? Anyone not convinced with this, please ask me. Udyan? Clear so far? Clear now, Udyan? Neil? Maulika? Vartika? Clear with this? Ali? Perfect. Next one. We have a hollow sphere with inner and outer radius. Inner radius R1. Let's take it as R and outer radius 2R. Now see, just because I said hollow sphere doesn't mean it's a thin shell. It's a hollow sphere with thickness. Okay? That is important. Why am I telling you? Because there is one idiot in your senior who did this thing. He read hollow sphere and he took there is no thickness and he was arguing ऐसा कैसा हो सकता है. So there we have a When you say hollow, meaning there is a thickness, it is a shell with some thickness. So this entire inside, right, you're maintaining at 2T naught. Entire outside is T naught. The heat is flowing again radially. It's not a disk, everyone. So this is radius R. This is radius 2R. This conductivity is K. So heat is flowing radially. Okay. So inner surface temperature is 2T naught. Outer surface temperature is T naught. Okay. Now, thermal conductivity K is constant. First thing, find R thermal resistance. Find dq by dt. Find temperature at a distance x. From center, where x ka value lies between 2R and R. Plot dq by dt versus x coordinate. Plot dt by dx, that is temperature gradient versus x coordinate. If k is variable, k is not constant. If k is variable and k is proportional to x power n, find n if temperature changes linearly. Meaning you want the temperature to change linearly, gradually from 2T naught to T naught. Let's get this. Exam mein, if I ask you, I would ask you this guy and this guy or this guy. These three questions. Those three are good. Let's start with A and B. Start from there. This is similar to that cylinder thing. So R thermal you can find. You take a, what will be the element? Onion ka shells. If you remember, right, this is what we did in moment of inertia and center of mass. This is what I told you. Doesn't matter which chapter you take. The way you choose elements will always be same. 1 by 8 pi kr. That looks right. Try everyone. Find R thermal and dq by dt. Those are the two easy ones. Then I won't get a lawn god. लॉन आएगा नहीं रे इसमें लॉन कैसा आया at a distance x take a thin layer taking a thin onion shell kind of thing. Distance x, thickness dx. So dr will be, length is dx. Again, L is the length along the heat flow. Here heat is flowing radially. So it is passed into the dx ka thickness by k. Area is 4 pi x square. All are in series. Integrate. R equivalent will be 1 by 4 pi k integral dx by x square. Limits will go from r to 2r. That would be minus 1 by r, 1 by r minus 1 by 2r, 1 by 8 pi kr. What is dq by dt? Temperature difference delta T by R equivalent. Doesn't matter what shape you get. ये तो हर बार valid है. T naught by that guy 8 pi kr. There. अभी temperature कैसे निकालेंगे? Find temperature as function of x. Try.
Can you
You
show
got a
the
minute.
questions again?
Yeah. Find temperature as function of x. Any doubts on this page, please ask me. I'll turn back to the questions. Cylinder में we took 2 pi xl. Sphere में will take 4 pi x square. बस, that is the only difference. एक बार R आ गया, then temperature difference by resistance. Why are you asking me, Adrit? I don't know that. You need to figure out. You are asking, is the current same throughout? Why wouldn't it be same? Whatever current starts from here, shouldn't the same current flow through each cross section? Arey God, that is the reason you took all are in series, na? The reason you took all the shells are in series because it's the same current flowing. Make sense? So, अभी temperature कैसे निकालेंगे? See, this is my suggestion. Let's say at this point here, the temperature is Tx. So my idea here is the current flow I should be also equal to 2T naught minus Tx by resistance up to x. Does that make sense? Whatever current is flowing from inside to outside should be also equal to the current flowing from 2T naught to Tx. Is that making sense? Because it is in series, isn't it? So let temperature at x be Tx. So current flowing current or heat from 2T naught to T naught, same as 2T naught to Tx. So what is the current here? T naught 8 pi k r. This is 2T naught minus Tx. What is the resistance? This formula here, 1 by 4 pi k integral dx by x square. Limits will free from r to x. Bas wo difference tha. Is that making sense? Limits will change. You need to find the resistance up to x. So here you found the resistance from r to 2r. Find the resistance from r to x. I'll just run the page. So that will be 4 pi k will go up. So t naught 8 pi k r. This would be 4 pi k 2 t naught minus tx. Niche integral is minus 1 by x. So 1 by r minus 1 by x. 4 pi k, and this will cancel. That would be 2t naught 1 by r minus 1 by x is 2t naught minus temperature at x. थोड़ा simplify कर लो, tx आ जाएगा. Please check the steps. There I got the temperature also. Remember, this is the process. You know, indirectly what I did, I'll show you. See, I wrote this thing like two resistors. And I said this guy is 2t naught. This is the first problem we did. Tx, and this was t naught. So let this resistance be Rx. This resistance will be R equivalent minus Rx. So I'm saying the current flowing in the total circuit should be equal to current flowing from 2t naught to Tx. Isn't that the same thing we did? Please check the steps. What's the next one? Plot the graphs dq by dt versus x and dt by dx versus x. Temperature gradient versus x and heat flow versus x. Do have a look at this page. I'll show back the questions. Any doubts? Anyone not convinced with this? That's the integration there. Meaning integration is fine. We'll get it. Get this. Still, there are two more parts. E part is a good one. Plot the graphs. Let's see how do you get it. Actually, now this guy and this guy are connected. Try. 2 minutes. Any doubts on ABC part? Please ask. It's a pretty good question. Meaning this will cover a lot. Advanced proper paragraph question this is. Anyone, any doubts? Not convinced, not clear, please ask. Graph is easy, right? What is the first graph? dq by dt versus x. How does this look? Remember, graph starts from r, okay? Graph ends at 2r. Constant. It's a straight line. Isn't it? Heat flow change nahi ho raha hai na? No matter at what distance x you see, the amount of heat flowing per second is same. That's why they're in series. Fair enough? Next thing, dq by dt is also minus ka dt by dx. So here, dt by dx. Now remember, this is constant. K is also constant. So dt by dx is proportional to minus 1 by area, which is minus 1 by 4 pi x square. So if you plot dt by dx versus x graph, it would be something like y is equal to minus 1 by x square types. So this is how the graph looks. It's a decreasing function. Yeah, or it's like y is equal to minus x square is this. उसका minus sign be like this. We'll just find mod, okay? Fourth quadrant में होना चाहिए ना? We'll just take mod of this. Temperature gradient, we just take the magnitude. So if I just write down this thing, dt by dx should be, what is dq by dt? Calculate तो किया, डाल देंगे directly, वो best है. T naught 8 pi k r by k 4 by r x square. This is minus 2t naught by x square. So it's like y is equal to minus 1 by x square function. We'll take a mod, so it is like x square y is constant, looks like a hyperbola. So PV graph जैसा दिखेगा. Clear with this? Yeah, or if you don't take that, so we have to put it in a fourth quadrant. So let's not do that. dt by dx, anyway, we're interested in the magnitude only. At what rate is the temperature varying? It is decreasing. Any doubts on the graphs? Please ask me. Last part. Suppose k is not constant. K is changing as a function of x power n. Find n if the temperature changes linearly. यहाँ पे देखा temperature कैसा change हो रहा है? If you see the temperature here, it is changing in a pretty weird way. 2t naught minus 2t naught 1 by r minus 1 by x. It's not a linear function. So 2t naught 1 minus 1 by r plus 1 by x. This is how the temperature is changing.
सर आपने एक R मिस कर दिया था सेकंड स्टेप में, वो नीचे आएगा.
कहाँ पे इसमें?
हाँ 2t naught.
हाँ, एक r भी होगा ना? Yeah, so this will be r and r. तो वो cancel हो गया ना? नहीं, 2t naught 1 minus 1 plus something I goofed up. नहीं,
हाँ सर ये 2t naught by x है.
dimensions match नहीं हो रहे ना रे?
नहीं
I forgot something somewhere. क्या भूल गया मैंने? T naught r
1 by x minus 1 by
1 by
x minus 1 by r. No, okay, got it.
नहीं, वो
नहीं,
माइनस साइन आएगा ना? क्या बोल गया मैंने? मोटेल
R by X.
2t not r by x.
ये r by x है
R
ना
by
रे? Yeah, you're right. देखो, if you see this function is not linear ना, 1 by x है ये. So I want a function in the form of linear function. So what should be k का value? Finish off last one for the day. You're saying temperature is a linear function, so it's like ax plus b. So basically dt by dx is constant, isn't it? हो गया ना equation? So dq by dt is equal to minus ka dt by dx. Now in this function, heat flow, this is constant. It will be different, but this is still a constant. This is also constant. So bacha kya then? So k is proportional to 1 by area, which is 1 by 4 pi x square. So proportional to x power minus 2. Therefore, n is minus 2. Easy. So k ka value should be something like some constant into x power minus 2. So when the mean temperature is varying linearly, indirectly saying dt by dx is constant. From there you can figure it out. It's a good question. You guys should definitely try this again on your own. I want to make it more fun. You can do something like, you can say k is equal to k naught x and then you solve. So I can change even k ka value while solving, isn't it? Any doubts on this function? Please check. Any step you're not clear, A, B, C, D. All clear? I'll give you a homework question. Try this and come. Next class we'll discuss. So we have a piston. The thickness of the piston is D. Area of cross section A. Thermal conductivity of the mass is a massless piston. Conductivity is K. And the whole setup is insulated. Piston is conductive, meaning piston can send the heat out. Inside you kept a heater also. The heater is giving energy at a rate of Q joules per second. So initially temperature is T0. It's a helium gas and there are N moles. Outside the pressure is P0. Temperature is also T0 here, just constant. So initially there is no heat going from inside to outside. Everything is fair enough. So once the heater is switched on, the inside gas will get heated up. So the heat will start escaping out. Let's assume heat flowing through the piston is small, so that we can assume it is always in a quasi-static process or equilibrium. Basically, quasi-static process, basically reversible process. You're not giving so much heat, like, the whole system gets messed up. Heat is given at a rate of Q joules per second, again, which is also small. First question, find temperature of the gas as function of time t. Now see what is happening, I'll tell you. When you switch on the heater, gas will get heated up. If gas gets heated up, pressure will increase. If the pressure increases, piston will move. On top of it, at the same time, heat is also escaping out because there's a temperature difference. Find temperature of the gas as function of time t. Speed of the piston. So the piston is moving, so uska speed bhi hoga. Speed of the piston as function of distance traveled. If the piston has traveled distance x, what is the speed? You might not be able to solve in detail, but get me the equations. Numbers are given, you could have solved. I'm giving all variables. There, I combined thermodynamics with heat transfer and with KTG. एक spring नहीं डाला, but ठीक है. Question is clear now what is happening. You will try this. So Friday when we catch up, this will be the first thing we will discuss. And make sure to solve the problems. We did almost 10 problems. Do make sure to go this, especially last 4 for integration problems. Do it by tomorrow. Don't delay it too much. You'll forget. Okay. So with this, we'll wrap up for the day. So any doubts, anything, do stay back or else you're free to leave. So take care, stay safe. I'll see you on Friday. I know you have a board exam going on, so carry on.